Hello, my lovelies. We are going to jump in. We're going to continue working on dividing whole numbers that are going to have decimal quotients or decimal answers. So I just want to quickly review the type of work that we did yesterday. Yesterday, we only did division with whole numbers that had decimal quotients less than 1. So that meant that our dividend was always smaller than our divisor. But that's not always going to be a case, which we're going to see today. So I want to quickly review what we did yesterday and just go over that one more time. So we can say 2 divided by 5 is the same as 2/5, 2 over 5. One really quick way that we can find the decimal quotient for this is to immediately convert this fraction into a fraction over 10 or 100. I can make 5 into a 10 really easily by multiplying by 2. Whatever I do to the bottom, I must do to the top. I can multiply by 2, and that would be 4/10. And I know, or 4 over 10, I just said it as 4/10. 4 over 10 is said as 4/10, and it is equal to 4/10. That's one really simple way that we can work through that problem, but we also practiced this strategy here where we did it in long division. We have 5 divided by 2. I'm going to clean that up. I don't want it quite so close to this other stuff. All right, let's do it right here. 5 divided by 2. So we know 2. Oh, I'm totally doing that wrong. Sorry, guys. Here we go. I hope you guys are catching all of my mistakes. We are doing 2 divided by 5 there. And we know right away that 5 cannot fit into 2 any times. So we're going to turn that 2 into an equivalent decimal. We're going to place our decimal and a 0. As soon as we place that decimal there, we also need to bring it right up here. Now we can say, well, how many times does 5 fit into 20? 5 times equals 20. 5 times 4 equals 20, and we have nothing left over. Now remember, I say 5 times 4. What we're really doing here is 5 times 4/10 equals 2. So that's a quick recap of what we did yesterday. And now I want to look into how we're going to look at that. Same strategies, but we're going to do it a little differently today with divisors that are smaller than our dividends. So we have bigger numbers here. That means our answers are going to include whole numbers and decimals. All right, if we were doing this all in fractions, we would call them mixed numbers, and that's kind of the same thing here. I can follow the exact same strategies. I can take this division sentence and turn it into a fraction. It will be an improper fraction of 5 over 2. Now I can do the same thing and get convert my number to an equivalent fraction over 10 or 100. So I know that 2 times 5 equals 10. And then I know I need to do the same thing to my numerator as I did to my denominator. 5 times 5 equals 25. Now this means 25/10. We know that's improper, and we know that what it means is we're going to have to regroup when we write this number. We know that we cannot write 25/10 with the decimal right here. That says 25/100. Think in your head what we're going to need to do. We're going to need to regroup this 20/10 into the ones place. They're going to become 2 ones with 5/10 left over. So 2 and 5/10. Now we can also do this using our long division strategies, just like we did above. We are dividing 5 by 2. We can say, how many times does 2 fit into 5? Well, it can fit in 2 times. 2 times 2 is 4. Very nice. We can subtract and we'll have 1 left over. We know that 2 cannot fit into 1. So, just like before, we need to create an equivalent decimal. Put my decimal and my 0. I know that I must carry that decimal up into my quotient. Now, I can drop this 0 down. and I can say how many times can 2 fit into 10. That's going to be 5 times. 5 times 2 equals 10. We have nothing left. All right, team members, so these are a couple different ways that we are going to be solving problems here. I really just wanted to show you guys that the strategies that you used yesterday are the exact same strategies you're going to use today. This is one reason why it's really important to keep our divisors, or our dividends and divisors straight. I know it's tricky, but not always assuming that we're dividing the bigger number into smaller pieces. Sometimes we're dividing the smaller number into pieces. Sometimes we're dividing the bigger number. So that's a really important thing to think about. I'd also like you guys to keep in mind a quick piece of review based on what I saw from our work yesterday. When we are multiplying to check our work, our answer, our product for that is not always going to be the largest number when we're using decimals. All right, so if I were going to check my work for this one up here, I would actually be multiplying 4/10 by 5 to equal 2. All right, to check my work, I would go 4/10 multiplied by 5 equals 2. All right, I know this is funky. It's not what our normal multiplication sentences look like, because normally our product is the largest number, but when we're using decimals that are less than 1, it's not always going to be that case. Now, for this one here, I would be multiplying 2.5 by 2, and I would be saying 2.5 multiplied by 2 equals 5. Alrighty, and we can always check that, but in this case, because our decimal number is greater than 1, then our product here is going to be the biggest number. So those are just a couple quick reminders for you today. My real goal here is showing you that the strategies and skills you practiced yesterday are the same ones that you're going to be practicing today, even though some of those division sentences might look a little bit different. I know you're going to do amazing. Keep up the good work. Remember, if you have a question on something, you can reach out to me. You can also write that question down and bring it to our video chat meetings at 1 o'clock or anything like that. So, miss you guys a lot.